All right, we're going to continue with this graph and density problem set. In the previous video, we had this graph of mass versus volume, and we determined that the density of this material was 3.55 grams per centimeter cubed by figuring out the slope. And we did a couple problems, and now we're going to do a couple more here. So, using the density, determine the volume of a 50-gram piece of the material. We've got to use the density because the graph only goes up to 45 grams, so we can't just read it off the graph. So, how do we find the volume given the density? Well, we know by definition that density is mass divided by volume. Well, we gotta get volume all by itself, and preferably on the left side. So to do that, we're going to use some algebra. I'm going to go through it step by step. There are quicker ways to do this, but I want to get the volume on top and on the left. It's currently on the bottom. So if I multiply this side by volume, I must multiply this side by volume. These volumes reduce, and I have volume on top on the left, but it's not by itself. I want to move that density over, so I divide this side by density and divide this side. Whatever I do to the left, I got to do to the right. Basic algebra, which you should be competent at for this class. Density over density reduces because that divides to become 1. Volume times 1 is just volume. All right, a lot of crossing out. I got just a V over here, an equal. I've got an M and a D. So I've got that volume is equal to mass over density. And my units should cancel out too when I'm done. If they work out, my units work out properly, it's a good chance I have this set up right. So I have a mass of 50 grams. We're going to say that's 2 significant digits. Really should put like a 50.0 on that. The density we got was 3.55 grams divided by centimeters cubed. All right, so if you know anything about division and fractions, dividing by a fraction is multiplying by its reciprocal. So this gram is going to reduce with that gram. That's good. And since I'm dividing by this, it's going to flip up on top. I'm going to end up with centimeters cubed on top because of that. So units seem to work. I have volume units on the top. That's what you should have when you're solving for volume. Now I can just plug in those numbers. Whoop, it's not 3.33, it's 3.55. I think I said 55, but I wrote it not so clearly. All right. I'm again going to use the entire density I found earlier and round at the end. So that gives me 503. And I should have put a 50.0 there for 3 significant digits, so we're going to say there's 3 sig figs there. And that gives us 503 centimeters. Nope, something's wrong. I multiplied times 15. Why did I have a times 15? Yeah, I did something wrong there. Let's redo that. I got to do 50 divided by 3.5. I don't even have that in there. Apologize. Let's do that. 50 divided by the density. The density. There we go. Now it's set up right. Oh, 14.07. So I knew that 503 was wrong because I knew it was just slightly past this 12. There's nothing like 500. So right there I recognized I did something incorrect. And it should not have been nearly that big. And so when we have the mass divided by the density, we get the volume, and the volume should be 14.1, not 503. 14.1. So always check that your answer makes sense. Right, I did a careless error on the calculator, and the answer did not make any sense, so I quickly recognized that I made an error. All right, here's another problem we got here. What is the mass of this block? You have the following block of that same material. Well, what's the mass? Well, we figured out our equation for mass earlier by using some algebra, and that mass of an object can be found by multiplying volume and density. So the mass is going to equal the volume times the density. But I got the density, that's 3.55. I do not have the volume. I've got to find that volume. Volume here is length times width times height. So I got 1.5, 1.5, and 2.8. So .3 is my volume. 6.3 centimeters cubed. Only 2 sig figs there, so we're going to stick with that. Now, my volume, 6.3 centimeters cubed, times my density, 3.55 grams per centimeter cubed. Check that my units, I got a centimeter cubed on top and a centimeter cubed on the bottom. They reduce to 1. I'm left with grams on top. That makes sense for mass. So I take that volume and I'm going to multiply it by the density. I am once again going to use the entire density from earlier on. And I get 22.38. We want to have 2 digits, so that's 22. 22.38 or 22 grams. Rounded to the correct number of significant figures. And this last question, what's the density of the material in kilograms per meter cubed? I'm going to do the whole thing. Some of you might already know how to do that conversion in your head, but if I've got 3.55 grams per centimeter cubed, get rid of the grams first. I've got 1 kilogram is 1,000 grams. Centimeters cubed, I got to get rid of that 3 times. Centimeters, I got 100, and I want to go to meters. 100 centimeters is 1 meter. That's one of them. But I'll write smaller. 100 centimeters is a 1 meter. That's 2. I got 3 because it's cubed. 100 centimeters is 1 meter. That's 3 of them. So 3, 1, 2, 3 meters cubed on the bottom. I can multiply that all out, and I get 3,550 kilograms per meter cubed when I multiply that out. Okay, there's the front page of that sheet.